So in this question, a ball is thrown straight up in the air with the initial velocity u. Air exerts a force on it in a horizontal direction, which produces an acceleration depending on its height above the ground, and which is given as a of x is equal to a h square. So we are going to find out the displacement of the ball from the projection point as a function of time. In this case, it is given that acceleration in x direction, that is a of x, is equal to a square, and let us suppose that this is the x direction and y direction, and h is a function of height, so we can say that h is a function of y. Okay, from here we can write that h is a function of y, h is function of y, so it means a of x will be equal to a y square, and also the acceleration in y direction will be given as minus of g. So if we use the kinematics formula, that the distance s is equal to ut plus half at square, where s is equal to y, so y will be equal to ut minus half gt square. So let us call this as equation 1. So if we substitute the value of y in equation 1, we can write that from equation 1 ax will equal to a times ut minus half gt square whole square, and acceleration can be also represented as derivative of velocity with respect to time t, and we also open the bracket, we get a u square t square plus a g square t4 divided by 4 and minus a u g t cube, and this can be further written as v of x is equal to a u square t square plus a g square t4 divided by 4 minus a u g t cube and derivative of t. Now if we integrate this equation from 0 to vx in the velocity side and 0 to t time on the respect to time, we can write vx can be written as a v square t cube divided by 3 plus a g square t5 divided by 20 minus a u g t4 divided by 4. From here we can also find out that vx is equal to, we can say vx is equal to dx by dt, okay, and rest of the things will be same, divided by 3 plus a g square t5 divided by 20 minus a u g t4 divided by 4. Now this equation can be modified in the same way which we did for the velocity part, we can write that dx is equal to a u square t cube divided by 3 plus a g square t 5 divided by 20 minus a u g t4 divided by 4 and derivative of t. Now integrating with respect to 0 to x and 0 to t, we get x is equal to a u square t4 divided by 12 plus a g square t6 divided by 120 minus a u g t5 divided by 20. So we have both the coordinates of the ball. We have x coordinate and we already found out y coordinate. So y coordinate was as y is equal to ut minus half gt square. So we can say that displacement r will be equal to square root of y square x square, where value of x and y is given as by equation 2 and equation 3. You can see that where x is given by equation 2 and y is given by equation 3. So in this way we can find out the displacement coordinate of x and y with respect to time, that is dependent upon as a time function. Thank you.